Okay, good morning everyone. This is the second session of Chapter 3. When we're talking about input and output operations. So last time we talked about the input and how we actually determine how to input into our system and how do we store the input values. And how do we handle input failures. So now we also need to look at output. The output is based on the Cout. Cout is basically the O-stream variable, right? The outstream variable. Now that outstream variable can handle expressions or it can handle manipulators. So far in the course, we only looked at expressions or literals when you displayed a literal string for the users, but not the manipulators. So in this section of the chapter, you're talking about manipulators. How do we manipulate the output on the screen? And how is the value printed onto the screen? So one thing that you need to notice, that every time when you see a function. Remember the function, what we were talking about? A function is, let me clear this, okay? So a function is a name, and the name needs to contain an input value, or we need to know what is the input into that function, and then we also need to know what is the output from that function. So if you have a manipulator in this chapter, any manipulators that you're going to see, if it has parentheses after that, after the name, and it has some kind of a value, then you need the library. You need the library IOManip. So in the preprocessor, you need to specify to load the IOManip library in order to use manipulators that do have an input parameter. Okay, so this value of the sending in between the parentheses, that's what we call an input parameter. Now you see that this is the fixed. Fixed is a manipulator, but fixed does not have the parentheses after it. So fixed does not need the IOManip library. And same thing with the scientific. Okay? So those manipulators do not need the IOManip. They're going to be handled by IOStream. Now if you want to unset any of these manipulators, here's the syntax. Right? So onsetF is also a member function. So Cout is, you want to call that an object. Inside the object we have functions. One of the function is onsetF, and the parameter in this case is going to be fixed. But in what namespace that fixed keyword is in, that manipulator is in? Well, it's in the iOS namespace. Remember, the colon is called a scope resolution operator. So fixed is in iOS scope. We'll learn later on what a scope is, but basically in what box. And that's the input parameter to onsetF. Now we have a show point. Show point is also a manipulator without any parameters, so you do not need IOManip for that. Okay? So why would you do that show point? Well, if you have something like, let's say, float x, okay, and that's your variable. If you say x equals, let's say 12, okay, you don't have a decimal value to it, right? It's going to be storing this 12 value, and when you try to print it out, and let's say you have you're going to print out something like 12, and then you're going to print out 3.15. Now, if we're talking about, let's say, a receipt, right, you can see that these two values are not aligned. Okay, so if you want to later on have a fixed value that also shows the point, right, then when we printing it out with cout, that's how we manipulate. That's how we manipulate what needs to show up on the screen. Then it will print out the dot, the period after the 12, and then usually it's going to be either 5 or 6 decimal places also going to be printed out. Okay, so you're showing the point, and then later on we talk about the precision, because what you want to print out is, let's say, 12.00 and then 3.15. So how do we make sure that all this is right aligned, so the dollar values, if this is a receipt, and the cent values, the fractional values, they all align. So it is a design decision. So when you are writing this code, you need to make sure that you design and you have a basic idea how you want the values show up on the screen. Now when we are printing something out onto the screen, and let's say we have x equals 5 and y equals 15, okay, and we just want to print it out. If you just want to do cout x and then y, what that's going to print out is 5, 1, 5. So there's no space in between. So if you do not use any manipulators, if you're not using the manipulators, the value is going to be printed to the minimum space. So if you want to separate these values, 5 and 15, that's when you're using the set W, when you're setting the width of the output. So just like last time when we were talking about the input, okay, the input is a string, and think about the screen. The screen has these little areas where a character can be printed. Okay, so if we find character space on the screen, in this case with set W, we're going to say to reserve 5 spaces for x. And then, in this case, if we also want to print out y, if we would print out y, it would print out y right after the x reserve space. So we're printing a value to a larger space. So if we are printing this value to a larger space, where do we print the value? Do we print it to the left or the right? So in this case, if x is 5, 5 will be printed right aligned in that space. So then when we print out y, y would be also printed out. But if we do not use set W, y will be printed out right after x. So what we need to do in order to separate these two values, because right now it's going to look like we indented the value in the space. So we're not starting on the left-hand side of the screen, but we're reserving 5 spaces, and then we printing on the right side of that reserved space. So how do we align it to the left? Now, with the left manipulator, okay, we can take this 5 and we can tell the system, do not print that to the right side of the reserved space, but print it to the left side of that reserved space. Okay. So we can use other manipulators like the set fill, left, right, and onset F manipulators. So the set field manipulator is going to be interesting because you might say something like hello. You want to print on the screen, and then you want to say 15. Now, in order to show that this is on the same line, what we can do is maybe print out dashes showing that hello is on the same line as 15. You can see that in receipts or table of contents in books. So in this case, what you can do is think about, let's say, either the hello as all this space, and then each one of the character occupies its own little space. Now in this case, hello is printed into a space, let's say 2, 4, 6, 8, and 11 spaces. So here the set W is 11. With the 11 set W, we're also using left. So left pushes hello to the left side of this reserved space. Now what do we do with the leftover space? And that's what we can control with the set field. So with the set field, the leftover space is filled with whatever character that we specify. So in this case, just a dash. So if you want to put an asterisk, then you can set fill to asterisk, and then the space is going to be filled with asterisks. Okay, so that's what the set fill manipulator is doing. Okay, so left and right, you can see they do not have parameters. So if they do not have parameters, you do not need IO manip library. Okay. So what other type of manipulators we have? Let's see. So what other type of manipulator we have? So we have set precision, set W, and set fill. We can basically talk about flush. Okay, so when we try to print something out to the screen, the system doesn't print out one character at a time. It would take too much time, too much effort. So what you do is the cout statement or cout object gathers data, and when there's enough data gathered, then at once flushing it to the screen, or we flush it to the file. But that's the basic idea about flush. And you used ENDL, which is just a case return at the end of the line. Okay, so now if we're trying to use CIN, now CIN as an operator will only read up to the white space. So if you basically want to read in somebody's name, somebody's full name, you don't know how many strings you have to read in. Okay, so somebody might have a name, X, Y. Somebody might have a name X, Y, Z. Right? So you're not really sure how many spaces are here. So how many characters to read, or how many variables you need to read it in. So what you would like to do is to take this whole string and read it, or take this whole string and read it. Now, CIN is not the right way of reading that, because you have spaces in there, and CIN will stop reading a space. So in that case, you have to use the get line. So with the get line, it doesn't matter how many words, how many spaces a user types in. As soon as the user presses the enter key, up to the enter key where the user started typing from, and up to the enter key, the whole string gonna be stored. Okay. Now, what is it that we need to do? And again, there's the generic syntax for this function. Okay. So we have the function. Function is the get line. So that's the name of the function. iStream variable. What is an iStream? iStream in our case right now is CIN. If we are reading from the keyboard, from the terminal, user input. So we need the IOStream library in order for us to have CIN available, but we are sending CIN and we're not using the stream extraction operator. We are using the predefined variable to send to this function. So this is one of the parameters to the function. Now the second parameter to the function is a string variable. That's where you're actually storing whatever the user typed in. So for that, we're going to have specify a preprocessor and use the string library in order to use string variables. So that's how you basically need to read these generic syntax functions as you're reading through the book. Okay, so syntax errors, if we make syntax errors or spelling mistakes in the actual syntax or the command or the statement of the function or in this language, that's going to be a syntax error, and the compiler will catch that, and it will record it or report it to us that the compiler will not create an executable unless you have a clear syntax. Now logical errors are different, because logical errors are going to be harder to catch. So the logical errors, when you're trying to maybe subtract two numbers and by mistake you add two numbers. So the compiler doesn't know what that expression is supposed to be. So logical errors are not going to be caught by the compiler. So logical errors you will have to use with testing. So that's why the way we started learning about programming is that we have the design, we design the code, we spend more time on designing the code. We spend a little bit less, hopefully a little bit less time on coding, okay? And as we're coding, we're compiling, and the compiler catches all the syntax errors that we make, so we can correct that easily. But when we're done with the code and everything is compiled, what we need to do is we need to test it. And when we are testing will catch any kind of a logical errors. So for testing, you need to know what's going to be the input value and what is the expected output value. And you need to monitor that, and that's how you know if the program works properly or not. And this is where we get to a concept that most people get confused about, the file input and file outputs, because most people do not feel comfortable using the file system. So it's really not going to be, most of the time, for those of you that are going to get confused by this, it is not C++. It is not the knowledge of C++ or syntax of C++ that's going to be hard. It is your knowledge of computers and how computers work, how the file system works. So you need to understand that, and probably this is going to be the section that you need to focus on the most. Okay, so it's just a 5-step process. Okay, so you need to have the preprocessor, the library fstream, and then we need string variables. Okay, and then we need to associate these variables with files, input files and output files. And then you need to think about it just like you were thinking about with CIN and COut. Nothing changes. We're still using the stream extraction operators, and we are basically using file access just like we use terminal access or screen access, output device access. The only thing that you need to feel comfortable with after you're done with the operations is to close the files. So you need to make sure that those files are closed. Okay, and that's pretty much what this chapter is all about. Okay, so input stream, output stream, C in, C out, other manipulators, other functions that come with the CIN, and processing files. Okay, so that's going to be the key point in this chapter. So let's see if we can launch Visual Studio and see if we can do some examples. So it's going to be very important that you do, as you read the chapter, make sure that you do look at all the source code that comes with the chapter and make sure that you understand, you run the source code, you compile the source code. Okay. So let me share my screen here. Okay, so we should have Visual Studio open, and like we talked about last time, just have a project created for learning. I like to just create a driver project, and later on we talk about the concept of drivers and stub code as programmers solve problems. So here I already have a source file which I don't really need, so I can remove that. Okay. I'm just removing it from my project. I'm not deleting it from the file system. So then I add an existing item to my project. So I navigate to my file system, Computer Science CUSC 1436, data files, and we are in chapter 3. Okay. So now you can look at all these different manipulators. Okay, and you can think about all kinds of different examples that will, or use these examples that show you all the different manipulators. Okay. So let's say left justified field. Maybe that doesn't make sense. Then you can look at that code and run this code. Okay. So here we are using files. Okay. So now if we have these files, okay. First of all, what I would say is understand the first step. The first step is you need to include fstream, right? So we have ifstream, which input file stream, and we have ofstream, which is output file stream. Both of those, the common denominator is fstream. So all of those data types are defined in fstream library. So we include that fstream. That's our step number 1. Okay. After that, what I would recommend, okay, what I would recommend is that you just implement everything as it was a standard CIN based and cout based application. So let me just get rid of these. So I'm just going to comment out the input and the output files. So maybe I want to modify this, and I don't really want to use the file input and output right now because maybe I don't feel comfortable with that. Okay. So I'm basically taking out all these contents, but I don't want to take out everything. Okay. So I'm just commenting them out. I'm not deleting it from a file because later on I'm going to use that. So let's say we have an X variable and we have a Y variable. Now if we have these two variables, how would you display them on the screen? Now we would probably display them on the screen just by, or let's say we're going to read into these variables too. Okay, so let's add another step in here. How do we read into those variables? Well, let's read into X and Y using the CIN. Now those, both of them are going to be integers, so we just need to separate them with a space. So before that, why don't we print out some kind of a message to our user? Okay, and we might say, please enter two integers separated by space. Okay, and I'm not putting in the E and the L, so the cursor is going to be blinking right after my message. Okay, so I have an output and I'm going to have an input. So then how would we print that on the screen? Okay, and here is where we would print it out to the screen. So that would be a cout, and I want to separate the two values by 8 spaces. Okay, so what is it that I need? Because it has a parameter, setW has a parameter, I'm using IOmanip in order to use those functions, or that particular function right now, which is setW. And that's all I need. So I have an input, I have a variable, right? I have variables, and I have an output, and I have input. And now we can format the output. So let's see what that looks like. Okay, so we put in the breakpoint. Maybe I put in the breakpoint when we have the initial values for X and Y. After we read into X and Y, so we can see the new values, and then we'll see how the formatted output looks like. So you run the code, okay, so the first time it's going to take a while for it to run. Okay, so at this point, if you click on locals, you can see that X value is 5 and Y value is 15. Both of them are integers. So they're not garbage value. They are declared as an integer data type and also initialized by the assignment operator. So let's continue on. Okay, now we have a prompt. So let me type in 20 space 30 and then press enter. So at this point what happened? CIN read the 20, the 20, and then it encountered a space. At that point it stopped reading and assigned the read value to X. Then it was kept reading because now we also had another variable. It find the first digit, ignore the leading 0, and the leading space, find the first and the second digit, and then it encountered another space. So at that point, it took the read values, the 3 and 0, converted it into an integer, and assigned it to Y. And that's what we see right here. The read operation actually worked. And we continue on, and as we continue on, we have an output, and you can see that the output is separated by spaces. Now, how many spaces? It's really hard to see right now how many spaces are separating or how the output actually worked. So let's stop this. And I think this is a really good way of working through this chapter. Okay, so in order for us to kind of see where we're at on the screen, we can just print out onto the screen this kind of character by character placement help line. Okay, I'll show you what I mean by this. But this is just something that we add to the code, so you will know exactly where we are on the screen. So let's just run this again. Okay. Again, the values are 5 and 15 for the two variables. We continue on, and we type in 20 space 30. Press enter. At that point, we verify that we did read 20 and 30, so those are proper values. That's exactly what we want to store. And now when we print it out, okay, now we have this helping line right here. So why would we print it out? Now, why we print it out is so we can see how set W8 works. So when we have set W8, you can count easily the spaces now by looking at the numbers right above the output. So this is going to be 0 is the first place. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. 8 is the place right here. Okay, let's see if I can draw a rectangle around it. Okay, you can see that this is the 8 spaces that we have reserved for X. And because we said left, the 20 within that 8 spaces was pushed to the left side of this box. And right after that, because we did not see anything for Y, Y is basically butted against those 8 spaces that we reserved for X value. Okay, so why don't we change that, and maybe we're gonna say set W, and let's do 10, and also push Y to the left. Okay, so let's see what happens then. So I'm gonna take these breakpoints out of here. I think you guys got the idea. Okay, so we run it, and I type in 20 space 30. Okay, and now you can see that the cursor is blinking right here, right under 8. So where is 20? 20 is 1, 2, 3, 4, 5, 6, 7, 8 spaces, and that's where 20 is printed. And 30 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spaces, and then the cursor is blinking, so it would write something after that. So maybe it is hard to see. So maybe I don't want to push it to the left. So if my design calls for, maybe I want to keep that to the right. I don't use that manipulator. It is your decision. It's your design decision. Okay? Type in 2030 and run it. Okay? And so what happened here? How come we are not pushing anything to the right? Well, because we set the left manipulator already. So we can do the iOS : and unset F, right? Or what we can say is, we can tell this specifically, explicitly, that Y is supposed to be printed to the right. Okay? So it's up to you how you're going to handle it. You have different syntax in this chapter, how you manage the manipulators. But basically, you have to look at what is printed where, and basically have a plan how you're going to be handling these values. So now you can see there is no separation in between, but if you look at it, 20 is printed into a space of 8, so 1, 2, 3, 4, 5, 6, 7, 8, left side of it, and then 30, which is the value of Y, has to be printed in a space of 10, So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And within that 10 space, you're pushing the value to the right side of that box. And now if we would print something, it would keep writing to the screen where the cursor is blinking. But let's say you like this, and this is exactly what you want. Okay? Now change this ID, but so make sure that you understand how to do it with terminal. Right? When the user is typing in values. Okay? So at this point, let's say that we want to write things to the file. Okay? What is it that we need if we're writing to the file? We have an output file stream. So we create a output file stream. Step number 1, include the library f stream. Step number 2, create a variable. Now when you create a variable, we need to link that to the file. So what file we're going to be writing to? So we're going to be writing to out.txt file. At that point, we have the out variable of ofstream type. At that point, we can output file. We can output to that file that we link to. So we're not printing this line of code to the screen. We are sending it to the output file, where the output variable is pointing to. At that point, we can also output to a file, output to the file using the same variable, exactly the same way how we used it with cout. Okay? So we can, if we like that format for cout, okay, we can just copy all that and paste it in. You're using it exactly the way that you would use it for cout. Okay? So when we're done writing to the file, what is it that we need to do? We need to close down, we need to close the out file. And that's it. And we run the code. Okay? We run the code. Now why is this screen shows up in the terminal? That shows up because we are reading. So we still have cout and cin for keyboard and screen, keyboard input and screen output. The user types in, and I put in 20 and 30. Okay, and at that point we still have an output to the screen. But at the same time, we also had an output to a file. So now where is that file? And that's when you need to know where you started your project. Okay, so in my case, it is in computer science. Okay, and I have a driver, the driver project. Okay, and that's where I cannot really help you with the file location, because you need to know where your files are. Okay, so then I go to my driver where my source code is, and look at that. That's when your output text file is. So when I double click on that, you can see we printed out exactly the same thing that we would have printed to the screen, to the terminal, but now it is inside this file. Okay. So what if we want to not ask the user for values, but we want to read in from a file? Now in the same location where you have your source code, okay, you can create a document. Just make sure that you only create a document, a simple document with Notepad. Do not use Word or WordPad or any other more complicated applications. It has to be something really simple application like Notepad. So let me call this input.txt. And you double click on that input.txt, and I'm going to put in, let's say, 40 space 50. Everything that I would have typed in on the terminal, when the terminal was running for CIN, I'm doing the exact same thing, the same style in my input file. So there is a space between 40 and 50. And I save it, and I go back to my code. Okay? So at this point, what is the first step? The reading in from a file. I still need the library fstream. What's the second step? Second step is to create an ifstream variable. So now we have an ifstream variable called infile. Look at the naming convention for the identifier. It's a camel casing. Right? So make sure that you are consistent. What's the third step? Third step is to open the file. Now here, what is the file that you need to type in? What's the file name? Well, whatever you created. So it's, in my case, it's called input.txt. Okay. So if it's input.txt, I need to make sure that I actually type in the same file name. We don't need to prompt the user anymore, right? This is not where we're going to get the new values from. We don't need the cout. We're not going to put anything on the screen anymore. Everything going to be read from the file, and everything going to be sent to the file. So we don't really need cout for terminal output. Now, can you leave it in? Sure, you can leave both of them in there. These are two independent variables. You can print to the screen and print to the file at the same time. But in this case, so I have an infile. I'm reading the values from the infile, and then I have an output file, and that output file going to print out the same help header. Right? This is just a header of numbers, just like we did with the terminal output. And then we gonna save this or print these values to the file. And then the fifth step is make sure that we actually closing the infile, not just the output file, but also the infile. So let's see how that runs. Okay, so I run this. Okay, you can see there is no output. There is no output onto the terminal. Okay, the terminal is empty. Right? I'm not asking the user for input, and I'm not printing anything to the terminal as an output. So let's go to the file system. Okay, now we have an input file that we created, and let's look at what's in the output file. Okay, now in the output file we have 5 and 15. So why is that? Why do we have only 5 and 15? So let's see where we made a mistake. If we made a mistake, right? So we stop the code, okay, and we look at the code again, and we're trying to see how do we make changes to X and Y? We make changes to X and Y by reading in value. Now, are we reading value from a terminal? No, not from a terminal. We are reading from the input file. So where do we read in from the input file? Well, we need to tell the input file. If we would read from the terminal, we would use this syntax, right? This is CIN, stream extraction operator X, stream extraction operator Y. But that's not what we want. Right? What we want to do is read in from the input file. So just because you have the variable, you open the input file. If you don't tell the system to read from that input file, it will not use it. So now we are reading in from the input file, and then we are printing to the output file, and then eventually we're closing both of the files. So let's run this and see how the output gonna change. Okay. So you can even see in the locals window that we have X and Y 40 and 50 now. So we successfully read 40 and 50. So when we open up the output file, you can see it is the same thing that we would see in the terminal if we would have used CIN and COUT for the output. Okay? And it's 40 and 50 because read that from the file. So what if I change this to 400 and 500? Close down the file, go back to my code, stop the code from running, run the new code. Okay, go back to my file system. go to my output, and now it says 400 and 500. Okay, so use the manipulators in order to output the values. So, see, we could do this exercise really quickly with the files that come with your book. So, if you're done with this exercise and it makes sense, then remove the source code and then add the new source code to it. Okay. Now, what happens if the input file is in a different path? So we can have the input file. Okay. Let's say I move the input file to my temporary directory. Now, if we are specifying a different path to the input file, then you have to double the backslashes. So if this is my code, okay, then I need to take my input file. I'm going to cut it from here. I'm going to navigate to C, temp directory, and in the temp directory, I'm going to paste my input file. So how does the system know where to read the input file from? Well, it knows by the path. But on Windows systems, the backslash needs to be escaped with another backslash. Remember in Chapter 2, the escape sequences? Look at that table. Okay, you're going to see that the backslashes needs to be escaped. Okay, so in this case, let me change this to maybe 4,000 and 5,000, just to make sure that we are reading from this particular file. So we go back to our code, execute it. Okay, you see how now the values what we read is 4,000 and 5,000. Okay, so when we go back to our output file, now it says 4,000 and 5,000. Okay, so the same thing you can do with your output file. You can send it to the same place. Okay, so now both of them are going to be in my temp directory. Run it again. Okay, stop running the code. Go back to the file system. And within the file system, you can see that we have the output file written, and it has 4,000 and 5,000 in it. That was processed by reading the input file. Okay, so that's pretty much what this chapter is about. The manipulation. You need to manipulate the output. So one of the best ways to practice output manipulation is to maybe look at some of your receipts in your pocket. Okay, so if you look at a receipt, you're going to see that a receipt, you can identify columns in receipts. All right. So in this case, you can see the columns. Okay. Here's a printed off value, and that value is separated by space and two values printed out. All right. Here we have columns that identify items, and those items, sometimes they have a dollar sign, sometimes they don't. So, and then you have one single string, and then a bunch of strings printed right in the middle of the page. Okay? So you can look at those as a columnized output. So let me show you this example right here. Okay, so what I would suggest that as you are planning the output, okay, just use Excel or a piece of paper, okay, and then try to figure out how you're going to lay out a picture of the output. Okay, so as you are printing out the contents of this, let's say in this case it's a receipt, right? You can see that you can pre-plan this. Okay, you see how you can pre-plan, and now you can really identify and say, I need this much space, and if I need that much space, right, just for the items, Okay, then I'm going to set my set W to this space. Now here's the number of items. So if you have a number of items, that might be a different space. So you need 2 characters for that space. And then I need all these characters to print out the item name. And then I need a space to print out the $sign. And at that point, I need to use the precision manipulator for the output, for floating point values, and I need to align all the output. I need to output all the numbers in this much space. And you can see that this is now a column for the values, column for the $signs, and now this is a kind of like a column or a space where you're going to print out the items and maybe the amount. Okay. So when you're separating, you can see here, you can just print all the space, print to the space, and use the set fill manipulator. With the set fill manipulator, you can draw all these dashes. So here, we can have the set fill manipulator to draw all of the asterisks onto the screen. Okay. So here we can use the set fill for the equal sign, use a string, and then set fill to fill the rest of the space with a bunch more equal signs. Okay. So this is what this code would look like. Okay. In order to create this particular receipt. Okay. And you guys can type this in and play with this if you're interested. Okay. But that's pretty much what this chapter is about. Okay. So make sure that you understand output manipulation, how you read from files, how you write the files, and how you output your data to your screen in a formatted manner. Okay. So I think some of you are going to get confused with this file system, handling the file system. So practice that a lot, and understand how computers work. What do you mean by path? In this case, the path is this / delimited words that tells you in what subdirectory you're in, with where these files are. So that is the path. And within the path we have files. So when we look at the code, you can see that this file, my input.txt file, is in this path. The path is delimited by backslashes, and because the backslash is a special character, we need to double those backslashes. Okay, but that's pretty much what this chapter is about. So let's see, there's no questions. So anyway, practice this and let me know if you guys have any kind of a problem. Okay, see you guys next time.